So we would be having a sort of agenda in each session. That a kind of setting a goal is always a good thing. So we are kind of setting a goal that this is how much we are planning to learn in this particular session. If time permits, we would be completing. If not, we won't be rushing through certain topic which if it's spill over, we would cover it in the next session. Post which we would go with the some sort of theory content of what is the basics of that, because direct BTP is something very new. If it would have been ABAP, I would have started with a normal ABAP coding, because I feel all of us would be knowing that. But when it comes to something new, it's good to know the basics. So we would be starting with the basics. It might feel like a bit of a theory part initially, but just be with me. I'll help you connect all the dots. So by end of the batch, we should be clear, and I would be there to help you with any of the doubts if you are having. Okay. And afterwards, in each session, we would be having a practicals as well. That is something that I'll be performing. You are free to perform those practicals now, but I'll suggest maybe in the interest of time, let's just focus over here. We will be having a recording of this session. After each of the session, I'll be sharing the recording with all of you. You can try hands-on at your own. Whenever time permits at your own. So it would be easy for you to focus over here rather than ultimately trying the same thing parallelly. And in case of system configuration or anywhere you are feeling any sort of trouble, I'll be there. Okay. So why we all are here, right? So the main thing over here is a BTP. We are all focusing on the business technology platform that we are all kind of discussing, that it is something new in the market. But why it actually came into picture? It was, I mean, we used to have a normal SAP system. We were happy with it. Ultimately, all the users, the business users were happy with it. But when it comes to a growing technology trend, when it comes to a scalability, there was some sort of issue. And that is where a concept came where a user would be able to pay as much as he is using. And that is why we come up with some sort of topic called cloud. Okay. So we would be learning what is a cloud and how it is, what is its working mechanism. It won't be specific to SAP. There is nothing specific to SAP. Cloud is a broader term. So we would be trying to understand how actually cloud came into picture, how it is working, the basics of that. Then we would be understanding BTP in the same constraint and its multiple component. We would be starting by setting our trial account, understanding the multiple component of that. We would be setting up the sub accounts, multiple entitlements are there, which we need to configure when we are using BTP. That is something we would be seeing. Then we would have a DB part. So let me just tell you one thing. We have our sessions that we are dividing. So BTP sessions are there, and we would be okay. What did just happen? Yeah, we would be having some sort of configurations that we would be doing. As a part of the configuration, we have multiple things. First, let's just say sub account. That is something we would be seeing. We have a database component. We do have a service, or I can say, yeah, external service subscriptions model. That is something that we would be seeing. We would be starting with our application developments as well. That would be using CAP, and we would be preferring Node.js because that is what SAP is recommending. And I don't want all of us to actually jump from Node.js to Java and Java to Node.js. We'll be focused on one technology because the architecture is same. Let's just first understand the architecture, then language is not a barrier. We used to learn C, C++ in our initial days, then we jumped to ABAP, and then we are now into Node.js, and we would keep on growing like that. Using the CAP, we would be generating the backend services. So what ideally an application contains? When I think of an application, ideally it contains an application ideally contains a platform, or I can say a infrastructure. Infrastructure would need kind of an operating systems and everything, post which it would have a database component. It would have some sort of application server. It would have some sort of UI. So this all builds my modules. Okay. See, this all builds my modules, post which we would be having, let's just say some sort of external resources. Because we all know a person alone cannot do anything, or I can say a person alone can do something, but to certain extent. For him to grow, we need to build a network. Same way, for an application to work in a versatile way, for it to be connected, we need some sort of openness. So these all the properties which I am writing over here has something to do with the BTP architecture. Okay. So the openness being one of the thing. If I am talking of the modules, then these are the DB application server UI modules. We would be having as a part of openness, we would have a integrations with third-party application. Okay, we would have a integration with third-party applications. Those third-party applications we would be connecting using something called resources. And this all the resources we would be able to connect because the application development platform which BTP is providing is a MTA based. And by MTA based, I mean it's a allowing us to create a multi-target application. When I say multi-target application, it can have multiple sources. It can have multiple resources from where it can consume the data, and it can give the output. It can behave as a backbone for the multiple application, though they are running separately. You can think of a banking domain. You can think of a banking service. A banking service ideally would provide an API. I have muted all of us just to avoid any sort of disturbance. You can unmute anytime in case you have any doubts. Okay. So banking service being one of them. Banking service is working standalone, but it has a kind of a architecture which is giving us all the methods, all the endpoints that any application which is requiring to consume its service can connect easily. And that is only possible once you have an application with an architecture of MTA. Okay, we would be seeing this. Just be with me because it's not an ABAP where we just have a reports or I can say some sort of objects. It is a project-based development, totally project-based development. Though those who have worked with a Fury development, UI development would be able to easily correlate with this some or more. Okay. So we would be learning the CAP Node.js backend services. Then using the CAP as well, we would be generating the UI apps. So mostly we are not going into core UI application development. Instead, we would be developing it using CAP architecture because we are not here to learn front end. We are here to learn what CAP is CAP is capable of doing out of box. So mostly it would be no code, low code based. And wherever required, we would also be learning extra logic that we can write because being generic is a good thing, but our all the business heads has some sort of deviation that cannot be achieved using the generic sort of development. Post which we would be having this UI application, so it would give us a UI, or in terms of BTP, I can say HTML services. We would be connecting those with the user access services. And those user access services would allow us to authenticate individual users, saying only authorized set of people would be able to use my application. Then we would be proceeding with the deploying, or I can say deployment of the application. And we would be seeing these applications are now available in the for the real use. So as a part of service subscription, we do have multiple one. BAS is something that we would be using the most. We do have some sort of external database like just a PostgreSQL. Uh, then we have let's just say some sort of logging service as well, some sort of workflow management. We would also be seeing how cross team can work together. So we would have some sort of GitHub. Um, I guess introduction to some sort of GitHub architecture. It won't be that huge because we know GitHub is something that we all have started working already. Okay. As a part of this session, let's just start with the basics that we need. So we would be first learning the cloud native architecture, its working mechanism, and all this particular component. And lastly, we would be setting up the BAS Business Application Studio, or I can say I'll be setting its workspace, dev workspace for the actual application. Perfect. Now let's just learn the BTP architecture, or I can say cloud native architecture first. It would seem some sort of a theory, but it's not a theory, it's a history. Why actually it came into picture? So we have a cloud native. Any one of you would like to tell me what is the difference between a on-premise and a cloud system? Anyone? A short one. Just to know we all are awake, we all are here. Okay. So
Cloud is user based, right? I mean, it's
kind of.
user specific. I mean, whatever. I mean, if you want to use a service, SAP is offering that. I mean, cloud. I'm not. I'm saying generic thing. As a
But
service, it is offered, right?
yeah, definitely it is providing services, and it is providing services in different way. So something as a service. You might have
Yeah,
heard of
so cloud
PSS,
has, I
SS.
believe, three: IaaS, PaaS, and SaaS:
Perfect.
infrastructure as a service, software as a service, platform as a service. So when a
Okay.
company goes for infrastructure as a service,
Hmm.
so the company would be, or the client would be provided with the hardware and software infrastructure till the security.
Perfect.
The platform and the data is always with the client. The platform and the software will be that of the client again if the client goes for us. If the client goes for PaaS, that is platform as a service, so infrastructure and platform are included mostly, and the data and software would be part of client's side.
Perfect.
And if client goes for SaaS, I believe the data has to be that of client. The software, platform, and infrastructure will be provided by the cloud company.
Exactly.
And
So it seems like we are going with some sort of subscription. Whatever we
subscription,
need,
right?
we can just subscribe that. Perfect.
Right,
Exactly.
right.
How and what
I
would be
I
the?
have just
Yeah, yeah,
one question,
yeah, yeah.
Sumit.
Please.
Uh, can like do like if I am going out from on premise to
Yeah.
cloud.
Hmm.
So would I be creating an infrastructure for cloud? Like from client perspective, the client
Hmm.
is going from on-premise to cloud. So
Perfect.
would the client think about creating their own cloud, or they go for subscription? I'm not aware of this part
So
because
So there are two sort of cloud technologies: public cloud, private cloud. There is also a terminology coming as a hybrid cloud. So public cloud is a kind of a cloud technologies, or where there would be a data center, but that won't be dedicated to one client. Instead, you would be purchasing or subscribing for a space where only your application, or I can say only your client relevant information would be stored. But in that same data center, there would be multiple subscribers information, subscribers application would be running in that particular infra. Many a time, whenever there is a very much data sensitive, or let's just say some sort of very sensitive informations, those need higher amount of security. Definitely cloud is also providing a security. But if I think of a sharing, what a sharing means, you can think of a data center as your laptop. If I have my laptop where I do have only one application running, all my operating systems capability, a firewall, everyone would be dedicated to that one application. It would work the more smoother way I can any time expect. But when I have 15 application installed in it, the operating systems capability to actually serve those would be splitted. So many a time, if I want a high performance, many a time when I want a very high amount of security, people go with a private cloud. So it depends on the use case, how sensitive, how I can say important it is to have the service live, available, and up to the speed. Because cloud has kind of multiple users when it comes to public cloud, and that might you might observe some sort of sharing in the resources, and that might result in some sort of performance deviation. And that is why uh, there are two options. Depending on your use case, you can choose one. We will be going deeper into that. don't be confused. Don't worry. Okay. And yeah, when I talk about on-premise, okay. So Ellen has explained very well what is a cloud. When it comes to on-premise, it's a kind of a setup where everything is being owned by that particular client, or I can say the person who is actually asking for that service. So for example, I want my internal network, I want my data centers, firewall, security, everything is something that that particular organization who is using that particular I can say application, or I can say, let's just say I am going with one SAP box. If it's on premise, I would have internal data centers. I would have my internal infrastructure team who would be handling what all patches to be installed, what all updates I have to actually do by time, all the compliance and everything. That particular organization who is using that has to bear all of them, and they have to be compliant, because compliance is very important when it comes to IT system. Okay, so with cloud, you are ultimately handing over that responsibility and focusing only on what your business needs, because rest everything is actually borne by the service provider. Perfect. So I hope you would have heard of one term. I'm not sure what are we well aware of that, but let's just say there used to be some sort of monolithic applications. There used to be a term called monolithic applications. When I say monolithic application, what does it mean? Let's just say I do have a big application over here. And here I do have a login service. Here I do have, let's just say logger, where my all the application logs are getting logged. Here I do have some sort of reporting services. Here I do have some sort of transactional. Let's just say I am getting all the uh, purchase requisition contracts and everything, whatever day-to-day transactions are there, those are getting reported. Okay. And here I do have some sort of, let's just say email services, where as a part of which all the emails are getting shoot based on whatever notification, or I can say some sort of notification service you can think of. This all is built, okay, in a, I can say, if I do have a monolithic application, if my an application is having 5 functionality hypothetically, then all those 5 functionality would be part of a single binary. And binary, I mean a single program, a single object that would be having all this capability, all this functionality written as a part of that. When there is a requirement, when there is a bug, or where there is a change in a logger service, let's just say, for example, hypothetically, that logger service has some sort of gray area that needs to be worked on. So we are doing some sort of changes in the logger service. We have fixed that. But when this particular service would get transported, would get migrated from the dev system to your dedicated production system, we can expect some sort of service outage over here. And it's not dedicated to logger service. This logger service is a must to have component for all this application. And is it's a 1,000 line of code, out of which line number 50 to 80 is having the logic for logger service. It means I am transporting my whole object. And if I am transporting my whole object for some amount of time, be it microsecond, milliseconds, or depending on the size of the application, there can be a few minutes or hours of outage that we can expect. And that sort of outage would result into some sort of production work outage. IT is a backbone of all the business. Okay, but IT is not something that we are selling physically. It should not hold a carrier. It should not hold a truck to get transported, right? And that is why if there is any sort of service outage, it would result into some sort of monetary loss. But this is what a monolithic application was having. So each time we used to decide, whenever I'm going with a rollout, I used to have some sort of system outage. To avoid that, um, cloud technologies, or I can say the application developer come with some sort of modularization concept, And that modularization concept is called a microservices. Microservices says, okay, you do have an application called, let's just say, um, material management, for example. Okay, this material management application, the whole related functionality that it is handling has a functionality for authentication and all this. So I would have an application which would have multiple resources, which would have multiple services it would be connected to. Okay. In case of any sort of change or upgrade in this dedicated service, I can expect only this service to get transported because this is a separate service first. Second, it may or may not be handled by the same team. There would be dedicated one team who is working on dedicatedly logger service, and they are providing this service for 15 odd applications. For email services, there is also one more dedicated team who is working. So those all microservices are there, are actually handled separately. We have just referenced it over here. And that is why it is called a microservice. It is a separate service which is being consumed just because we want that service in our application, but it's not part of our application. We have just connected to that. So in case of any of the change, I will just be updating this. My earlier application would keep on working as it was. There won't be any sort of system outage. No downtime would be required. Perfect. Now, in a cloud terminology, there is a concept. Okay, let's just go line by line. What used to be there in the earlier days? In the old days, what used to be is, let's just say we used to have some sort of dedicated, let's just say infrastructure, saying I want one application for database storing. I want some sort of media or n number of applications I used to have. So let's just focus on the first part first. So this particular for application, if I need, I used to have an infrastructure. Now this infrastructure, I can think of a RAM memory, CPU usage, some sort of security, or I can say some sort of firewall settings. Everything used to be there, and this all build my infrastructure. This is how the old days would look alike. It used to look like. Okay. Now, after having all this component, if I do have all this in place, along working on my application development, and I can dedicated application working on running on that. Now, let's just say I do have a small image viewer. A small image viewer, how much amount of memory it would need? Yeah, memory, I think it would need a higher one. But how much amount of RAM it would need? It would be working with a smaller one as well. That would be fine. CPU of a low configuration would also be fine. Likewise, we have a setup. We have a proper requirement of what all infrastructure that we would be needing. So if earlier we used to have 4 such application, we need 4 such infrastructure. Dedicatedly for one application, if I'm choosing, should I choose a infrastructure, a system with a lower configuration or a medium or a higher? So what ideally we used to do is, initially while I'm building the application, definitely a lower one would be fine. But going forward, I might end up with a huge amount of data, huge amount of, let's just say audience base. Then I might need a huge amount of capability as well. So let's just say I don't want to go with low configuration, instead just go with the higher. That's what let's just say infrastructure setup team would finalize with, that okay, I would go with a higher configuration. But what it is costing, you see, if I say, okay, give me the best operating system, highest amount of RAM, highest amount of CPU, it is ultimately costing us a huge in the term of cost, right? Even though that is not an application which might need that amount of, let's just say infrastructure setup on the initial or in the final days as well. But from a safer side perspective, the people are investing on the higher configuration, and which is costing higher to maintain the infrastructure used to be there in the older days. Perfect. So what happened is, you might have heard of an organization called VMware. VMware came up with a concept of a virtualization. What they told is, I do have a system which is having the highest amount of configuration. On top of this, let me just help you build some sort of virtual component. Let me help you build some sort of virtual system. You might have heard of the same terms earlier, that we used to have some sort of virtual system running. And let's just say in our college days, when we used to do some sort of application development, we used to have some sort of such virtual machines running on our system, where we used to install a dedicated operating system. You can think of a scenario where you do have a Windows system and you want to run a Linux. How you can do that? For that, we need some sort of virtual machine, and this virtual machine was being provided by VMware. So from there, a concept of virtualization came, that though I do have one system, I can have multiple components dedicated to that. Now, if I am saying that I do have 16 GB of RAM over here, I do have a 16 GB of RAM over here, but out of which, for this application, I want to dedicate only 4 GB. And for this virtual machine which I am creating, I want 8 GB of RAM to be allocated. I want a Linux to be installed over here. I want, let's just say, iOS to be installed over here based on my whatever requirement is. It would seem okay, rather than having 4 different machines, 4 different infrastructure for having the same, let's just say 4 applications to run. Instead, I can also settle in one application. And this was like a boom in the market, that okay, now I don't, the company don't need to pay 4 times if they want to go with a 4 application. But what used to happen is, if there are 4 applications which are running and there was a dedicated server, we came up with a concept called virtualization, where the virtual machine would be running. They would be having a dedicated amount of CPU assigned to them, server assigned to that, RAM memory assigned to that, splitted based on the total. That okay, I want 2 over here, 5 over here, and likewise. Operating system, whatever is needed, would be assigned over here. But what we are ending up with is 4-time license cost of operating system. The admin has to actually do the controlling, patching, update, antivirus, everything is needed for all these 4 boxes. Even though we do have a single infrastructure, the maintenance cost is ultimately potentially increasing. The maintenance time is increasing. That is one thing. The costing is something, let's just say, think, okay, this is an unavoidable task, we will do it. But what other thing it is hampering? I do have a server. You can think of a server saying I do have a huge capability of a server. One task just started working. That was the first one who actually kick-started its process. So it was fine. It was working smoothly. Going forward, second process just started its processing. As first task was working, it was getting some sort of delay, lagging in the response. You can think of a boot time, execution time. As it's connected to the same server, it is not performing up to the mark as it should be. So this virtualization concept was no doubt far better than what we used to have compared to the dedicated system. But this virtualization concept also was hampering to some extent, okay, because it requires all this sort of maintenance. Other than that, we also need to have some patience, because the load of this particular, let's just say, individual system would take a huge amount of time. You might have experienced that on your own as well, right? We, in our college days, in our, let's just say, some sort of local project that you might be doing, you might have done some sort of VMware installation. You might have gone with some sort of virtual machine installation, and you might have used the application. It used to take a huge amount of time. So think of an industrial application, how it would actually run smoothly in this environment. Then came up a concept of a containers. And this is a concept which is still there into the market. You might have heard this. there is a term called containerizing an app, containerizing an application.